That's the thing about me. I maximize.
You maximize.
Now, I'll show you what I mean. This circular cloth, if I have to cut out a big rectangle, well, I could cut out a pretty big one like this. Maybe bigger like this. But I find the biggest rectangle.
Yeah? Which one?
I don't know yet. Let's go over here and I'll show you another one. If I have this much string, length 10, and I have to fence off a big rectangle, I could fence off a pretty big one like this. Maybe bigger like this. I might even be able to make a bigger one.
You don't know.
I don't know. That's another one I have to maximize.
How do you maximize?
It depends. Now, if I have to fence off a rectangle with sticks, let's see, I have 10, then I could make one 2x3. Okay, what else could I possibly try? 1x4, that's the only other possible shape, and it's not as big. So, for this problem, 6 is the maximum.
That's too easy.
Sure, but if there were more possibilities, I could still just try them all and see which was the maximum. With a string, it's different. I have all these possible shapes. Infinitely many, actually. Can't literally try them all. But I can put them in order. From this to this. According to the length of the base, x. X equals 0 here. X can increase up to 5, half the length of the string. Every possible rectangle I could choose is named by a value of x between 0 and 5.
How does that help?
Well, let's see. No, I think I'll do that other problem first. It's easier. When I cut out a rectangle, well, it doesn't matter which way I turn it. Let's put it like this. The two halves are equal. It's really just a question of cutting a half rectangle from a semicircle. For all of these triangles, the base is the same. The altitude is what I have to maximize. And I can name my possible choices by this x. Let's start from 0. And the altitude's increasing with x for a while. And then after a while, decreasing. The maximum's in between. Over here, you could improve by choosing a larger x. Over here, you could improve by choosing a smaller x. The maximum's in between. It's a square.
That was easy, too.
I know. But could you see what I look for? If a function's increasing, then its graph rises to the right. If it's decreasing, its graph rises to the left. So those points aren't hop points.
Right.
Ha! Look at that lamp. Ha! Better get a ladder. I'd like the point of the ladder, which is right under the lamp, to be high up. Which way will it be highest?
You got to maximize.
Yeah. Now let's see how to put the possible positions in order. Well, I could start from here. The base of the ladder, as close to the wall as the lamp is. Then I could try the other positions. I put them in order according to how far the base is from the wall. That's x. X can be as small as a. Then all these other values of x up to L, the length of the ladder. In between, different positions x correspond to different values y of the height of the point under the lamp.
Y is what you're maximizing.
Yeah. Change x from A through all the other values up to L. In between, y is positive.
Maximum somewhere in there.
Now, I know in a position like this, dy by dx is positive. Graph rises to the right. Then in a position like this, graph rises to the left. So they're not top points.
Where is the maximum?
I don't know. I'd have to find y as a function of x, so I'd could compute the derivative.
Right.
It looks a little harder. Let's do this other one first. With this string, I've got lots of different rectangles to choose from. I'll name each one by the length of its base, say x, or its height, y. I wouldn't need to know both, because the string's length is 10, and that's the total length.
So, if I know x, I know y. Just solve. Y is 5 minus x.
So each rectangle is named by its base, and that puts them in order. From x get y equals 0, x is 5. For each one of these choices, I get a certain area. It changes when x changes. When x is 0, it's 0. It must increase when x increases. After a while, it must decrease, because when x is 5, it's down to a 0 again. Where in between do the increase stop? Or does it reverse direction of change more than once? I'd better find exactly how the area depends on x.
Well, you can differentiate that.
Sure. And I see this derivative's positive for x less than 5/2, negative for x greater. The area as a function of x looks like this. Maximum at x equal 5/2. It's a square.
Well, naturally.
Well, it might not be so easy to guess if the rectangle had its bottom provided. So my string just has to make sides and top. Much the same as before, but the string makes only 3 sides. So we get... Can't guess the answer.
Not without doing it.
Yep, we'd better do it. Maximum at x equal 5. Not a square.
Nice. Now, how about that ladder?
Yeah, maybe now I'm ready for the ladder.